You know what squares are, right? 2 square is 4, 3 square is 9, 4 square is 16, and so on. When we say squares, we are actually multiplying a number by itself. That means 2 into 2, 3 into 3, 4 into 4, and so on. Now I want you to pause and think. Do you see a pattern here? Some connection? If you guessed area of a square, then you are absolutely correct. And if you didn't, no worries, because what you just did forced your brain to seek patterns and draw connections. So here's the truth. Every square number represents an actual square. Whose side? You guessed it. It's the number being squared. Imagine these as squares of different sizes. 2 square equal to 4, a square with all sides of length 2. 3 square is equal to 9, all sides length 3. 4 square is equal to 16, means all the sides of this square is 4, and so on. So basically, these squares are just part of a massive collection, a set of squares of different sizes, from side length 1 to infinity. Now if I ask, this square has an area 49, what's the side length? You will say, hey, that's easy, the side is 7. Exactly. And what you just did is solve under root 49. So when we say square root of a number, we are actually imagining that the number has an area and we are asking, what is the side length of the square with this area? Which means the square with area 49 has sides of length 7. Under root 49 is equal to 7. In terms of positive number, there is no problem at all. But nobody dared to apply this analogy to the evil twin of natural numbers, the negatives. Why? Let me explain. Let's start with under root minus 1. Under root minus 1 says, I am the number which when squared gives minus 1. Okay, so under root minus 1 square is equal to minus 1. But no matter how far you go on the number line, there is no number whose square is negative, because the basic rule says 2 into 2 equal to 4. That is positive. Minus 2 into minus 2 is equal to 4 as well. That is also positive. So you can never get a negative number by squaring a real number. Euler represented under root minus 1 as I, and René Descartes coined the term imaginary number. Yeah, the I think therefore I am guy. But did we force this number to fit on the real number line? No. Let's make sense of how this works. Imagine the real number line has a line where each number is 180 degree apart from its negative. From 2 to minus 2, there is 180 degree rotation. Applying this analogy, if we multiply I into I, we are getting minus 1. Now, let's multiply I to minus 1. We get minus I. Let's multiply minus I with I. We get 1. Do you see something here? We are getting 4 numbers. Minus 1, I, minus I, and 1. Minus 1 and 1 lies on the number line. But where does this I and minus I lie? Do you remember I said there is a 180 degree difference between any number? Correct. Minus 1 and 1 has 180 degree rotation. So where does I and minus I lies? Every time we multiply by I, we are rotating 90 degree around the origin. This cycle is why the imaginary plane is perpendicular to the real line. Every multiplication by I rotates the number 90 degree around the origin. What this means is that now we have built a coordinate plane. The x-axis is the real line. The y-axis is the imaginary line. Can we plot this? Of course we can. Take the real part 2, imaginary part 2i. You get z equal to 2 plus 2i. Congratulations, we have just created a complex number. So, from just squaring numbers 2 into 2, 3 into 3, we ended up discovering a whole new direction for number to exist in. Like, who would have thought that multiplying by I would rotate us? That number could actually turn, not just move left or right. And when we took real numbers and imaginary numbers, we created this entire complex plane. And that number we plotted 2 plus 2i. I hope you like this explanation. If you have any questions, feel free to ask in the comments. I will make sure to reply to everyone. And if you want to go deeper into complex numbers, more creative, and maybe even a little weird, Just let me know in the comments. I'll make a part 2. See ya. And for the cosmos.